why. It's one of the most useful controls. And whenever I share the screen, that control goes back under the more category. I don't know if you've ever hosted a meeting. Okay, so what I started saying and I realized I should record for people who haven't seen this before is if you this is a different way to make this is just a Google Drive folder. So this is our shared one for the class. But if you made one of your own and you want the Colab to appear in there, if you do it the other way we said the very first day of class, if you go under here and you say File, New Notebook in Drive, if you do it that way, it will create the file by default in your Google Drive, My Drive Colab folder that it made for you. So if you want it to appear, so don't do it that way. So click out of there. If you want it to appear in whatever, like if you made a folder for this class, it's buried, but you can say the new, oops, sorry, I did not want to do that, not a new folder, but you can go under the new button. And for mine, it's under the more. If you have a big enough screen, maybe it'll all show up. And if you see, whoa, way down there, there is the Google Colab button. So once you've made this, and this doesn't appear if you've never made a Google Colab file before, interestingly enough. So as soon as you've made your very first Colab file, after that, you can always make a new one this way, and it will appear in the correct folder. Like it will appear in the folder I'm in right now in Google Drive, making the new. I won't actually click the button because I have one already started for us. But if you ever want to make a new one in a particular directory, that's a short and easy way to do it. All right, so more on variables and the variable inspector, which is a really useful thing that Colab has that I believe the Anaconda Jupyter Notebook does not. We can double check that when we get that far in the semester. Let's see if I want to make, oh, this is a code cell. Let me put one more text cell for you all. This is not so, this is just formatting. I mean, unless you like, I like the outline. If you like the outline. If you like the outline, then you want to do something like that. So far, we've seen things like integers, floats. So far, you can always make a comment like this too. Integers, floats, strings, and we have seen the very first array, but I'm going to talk more about array. One of the things I'm going to do today is talk more about arrays. But you've seen linspace, which is an array, which we talked about before because we've seen the type thing. All right, just it slightly matters. I want an integer, a float, and a string for right now. So I'm going to define x equals 5 as my first integer, y equals 2.5. The particular values aren't, but an integer and a float and a string. My name, Jessica, and it will keep the capitals. And then I'm set of blank space. I'm a big fan of blank space for readability. And let's do some print statements just because print x is, and then there are a lot of different ways to do this, but for today, let's just keep doing it this way. And it is type. I can't remember if I need a space there. I think the comma will do it for me. And then you just want to remember the command to see the type of variable it is just type x. And then the same thing for all the other ones. Let's just cut and paste that. And then I'm going to switch, and hopefully I remember to switch them all. So x is, I don't want 3 lines, x is, y, my name, y, my name, y, my name. All right, I think I'm ready to hit shift return. Oh, this is what I was saying to Noah, and you probably figured this out. That day I was doing a class where I had some cells already filled in, and it didn't do that nice when you hit return. It opens up another code cell for you, which is really nice. If you're in the middle of coding, it's really nice not to have to like back it up and add it yourself. It's sorry, Annika, I said I slow to watch chat. I there's a lot of evidence that handwriting, taking notes is the best thing. This is just a question about like whether you want to. I'd probably suggest typing along while I'm doing this. Um, but if you want to take notes or this file will exist, you can come back and look at this file. But it's always nice to do it yourself. It's just somehow a lot more meaningful if you're doing it yourself. Okay, so cool enough. That should all have been reviewed. We did all that before. Okay, here's a new thing, and part of the reason I'm doing this new thing is because I'm going to I want to give you Professor Lee's book, which a couple other people asked to have right away, even though he says he's still editing it. I'm going to give you Professor Lee's book today, and it it needs some translation because it's fantastic. The content is fantastic, but he starts out assuming that you have installed the Anaconda, and I am using Colab. So that there's just a little bit of translation there, just a little bit. So let's make this its own. So the variable inspector. This is a super handy tool. Yeah, I just can't even say enough about it. Super handy tool. And it is I'm just putting these marks to make, this makes it look like type. It's the X on the left. Okay, so on everybody's Colab, so this is the kind of thing you want to have your own Colab open so you can see it. On everybody's Colab, uh, right here, so on this left sidebar, where I open up the table of contents, so if you want to see the headings I've made so far, to see the outline, close that, but right under that is an X, and it's a variable inspector that may impact runtime. What do you know? Look at that. It shows them. It shows all the variables I made, and it's showing them in alphabetical order rather than the order I made them in, which is fine. This panel is not big enough. There we go. It actually shows the values. This is super helpful to leave open while you are debugging code, and even writing code. So, uh, a lot of the times, part of the reason I've been showing you the print statements is if you're stuck in some environment where you don't have access to something like this, then print statements are your friend. You can always print the variable to this. You can do what we just did, right? You can print X is type, X is whatever value it is, and it's type whatever. But here we have this variable inspector telling us exactly. So X is an integer and it has a value of 5, and y is a float and it has a value of 2.5, and the string my name is Jessica. So that is a super, super helpful thing to use, and it is one of the reasons. Let's see, I had that one. So I don't know if you saw me, I clicked, there was like a little button in the upper, when it was on the left side, there was a little button in the upper left, and I switched it. It doesn't really matter where it is. I slightly prefer it on the right, but leave it open for now is what I'm saying. So if you are typing and following along, leave it open. And if you're just following me, watch what happens. I can just do it doesn't particularly matter exactly what the calculation is, but I can redefine things and it will show up immediately. So if I say x equals 3 and I do my shift return, watch the variable inspector, there it goes, and it highlights in green for you. It even shows you. So the x value just changed from 5 to 3. Pretty cool. So that's what I'm saying. It's super handy to be able to check variables that way. I also want to show you one more thing. Okay, so now let's say y equals 3 times x. Then x, y, okay, y, look at y in the inspector right now, and don't forget. So y is 2.5. You can actually scroll up the screen too. Y is 2.5 and it was a float. All right, now I'm saying y is 3 times x, but x is an int. Y just flipped, it's very slow here on my end of the world. Y just flipped to 9, which is indeed 3 times 3, and it switched to a integer. So I changed it from a float to that is called dynamical typing. So Python is a language, and I'll write this in just a minute. So Python, you can switch. There are some languages where you can't just do that. There are some languages where if you declare y to be a float, it has to stay a float. And Python will just do whatever it thinks, except for there are some exceptions, and I'll show you those exceptions in just a minute. before I do all that, just more things about the variable inspector. If I type right now, x equals 4, yet another new value, it was 5, it was 3, and now I'm going to make it 4. After I do that, okay, I'm cheating because you're seeing the variable inspector. What is x and what is y? Did you expect y to change? Because y is defined as 3 times x. So if I change x, did you expect y to change?
Not unless you
Glenn?
hit Shift and Y again.
Exactly, exactly. So right, exactly. Unless I run that line of code again, um, this is I have not. This is I don't. I think this is a weird thing that I had not noticed before. I wonder if Colab is different from the last time I taught using it, or I just don't usually leave my. I've noticed if I leave my cursor hovering over this cell, it has the arrow instead of the number of the number in the square brackets off to the left there is the order that I executed them in, right? And so I ran that y equals 3x before the x equals 4. So it doesn't do that until you run it again. Right. So whoever said that, yes, that's right. So basically it matters what order that I did that. Um, the difference between so integers are just count the difference between in the chat, the difference between the string, the float, and the integer. The integers are just counting numbers, right? That's just a math term. So and it's the same in Python and in math. Integers are just oh, and in Python, negatives are fine too. So you can have x be -3 and it's still an integer and 0. Um, it's only if you put the decimal point. So real numbers are floats. So float means a real number. And there's different precisions you can have on that. And we'll maybe worry about that later. But right now it doesn't matter. We just carry around some decimal points and it's a float. So when I go back to if I went back to y equals it was 2.5, I could make it whatever 12.5, 12.25. That'll turn into a float. So it's if it has decimal places, basically it's a float. And strings are well, they're really I mean, they're mostly used for letters, but of course you can put numbers in them and spaces in them. So strings are just whatever is surrounded by the quotes, it just kind of takes that literally. So, because we talked last time about like I could use right now I have my name is Jessica, but I could also do my name is Jessica Kintner, and I can put a space in there, and it'll preserve that. Which you could see over in your variable inspector, it does indeed preserve that space. And it will preserve other spaces too. I'm going to go back up and edit. So you can put multiple spaces in there. And you can't tell. Can't tell. Let's see. Print name. There we go. So it keeps those spaces. So basically whatever you put in there, it just reads it as literally those characters, and those characters become a string. We'll talk more about that. Okay, one of the many things I said, I promised to type some of the things I said. Python, the name for being able to switch typed. You can change variables from one type to another without much. In this case, I just did it by redefining them. There's also sort of more, if you want to take a particular number, if you want to take it, we'll show you this in just a minute. There's the more complicated ways to change things. There's actually functions to change from one type to the other as well, but I don't think we need to get into that yet. I don't think for anything you'll be doing so far, I want to get you enough to get through the couple ICs that we have here. So anything I do, anything that will get us there, I'll hold off for a second. So you can change the variables from one type to another just by redefining them, just like we just did. There's also some rules for variable names. Another text cell. So this will be hard to, gonna cut and paste this one. Um, tag for variable names. This was in Professor Lee's book. It's also in our book. But I'll copy it here. So it will also be, like I said, it will be in the one, if you don't want to type all this, that is fine. It will be in the one that we saved today from class. So variable names, they must start with a letter or an underscore. They cannot start with a number, but they can contain numbers. This one is the one that super annoys me. There's a whole bunch of times I wish I could put the number first, and you have to put the number second. So you can put like V0, but you can't put 0V. Okay, that's one that in physics you usually do want it after because you usually think of it as a subscript. So V0 is fine. Variable names can actually only contain, the underscore is the only special symbol it can contain, which is kind of old fashioned. So it can contain the capital letters, the lowercase letters, and 0 through 9. And we've already talked about variable names are case sensitive. So if you change any capital letter in the variable name, it changes the variable name. We've already seen obviously that X, Y, and Z are fine. You can also have underscore X equals, it doesn't matter, 50. So that one's fine. It'll give you an error message. If you just want to check, one of the cool things about it is you can just type it and check. You can hit shift return anytime, and it's just a cool way to type it and check. So any problems like that, you can just try it and see what happens. And 2x, which you can see why you wouldn't want that anyway for a variable name. 2x is 100, but it won't let me do that. So syntax error, invalid, decimal literal. So you gotta try to learn, you gotta learn to parse these. So you can't have the number as the first, but you can have x2. So you can say x2 equals 100. And that is fine. So it doesn't complain about that. So letters, numbers, letters, numerals, underscore is fine for variable names. It has to start with a letter though. That's about the only complication. Question so far? How are you guys doing? Holding up? All right, cool. Um, okay, so those are rules for variable names, which I just had not, I'm just listing them so that you have seen them before. I want to talk about, okay, here's a new kind that you haven't seen before. Have I used it before? I don't think I've used it before, but it's possible the book has. A new variable type, a list. It will probably be obvious what it is, maybe not. A list is, okay, now I'm going to use, I always still have to look. A list is square brackets, and my code complete is putting the beginning one and the ending one for me. That's actually pretty nice. You can make just a list of numbers, me and my wonky spacing, and that shouldn't matter as long as I have the comma there. An extra space looks nicer, but it shouldn't mess it up. Checking my variable inspector, yep, it's still there and it shows all the values. So that's a list. Do you want me to print it? Probably don't need to print it now that we have this beautiful variable inspector. And then blist, it also is a list, will also, like an array will accept strings. So apples, oranges, strawberries, print blist. Which again, I probably don't have to do since it's going to show up for you in the variable inspector. So now that you know the variable inspector, you don't always have to print unless the program. Sometimes sometimes you want to print because the Colab file shows the output, right? So if you're showing in, so you should. So one of the reasons I like the notebook so much is that I can see what you saw. So don't get totally out of the habit of printing things because you want the output sometimes on the screen deliberately so that your notebook shows the record of everything that you saw while you're working on it. Because I won't be able to see that. I mean, I can reopen it up, the variable inspector, but as you're seeing things change as you go, right? So I won't see the intermediate step if by the end you've done something totally different. So that's not a good thing for when you're turning code into me, but it's a very good thing for when you are debugging code as you're working through it on your own. One more list, and then I'm going to start playing with these and showing you what happens. C list. C list is another string of numbers: 10, 11, 12, 13, 14. I need to have this be the same. Oh, I started with 0, right? So, well, actually, do or don't need to have that be the same. Print the list. All right. What do you think will happen if I add? So A list and C list are both numbers. So what do you think will happen if I add A list plus C list? So you can see it in the variable inspector. So A list was the 1, 2, 3, 4, 5, and C list was 10, 11, 12, 13, 14. What do you think will happen if I add them? If you know Python, you might know the answer. If you're thinking mathy, you won't. It's not an array. It doesn't add like an array. So when you add, so a list is more like thinks it's strings. Even though it's not strings, it is, I mean, a list is its own type of thing. So it appends them, by the way, which is kind of like what the strings, I said it's kind of like strings. If I say my name is Jessica, and then I say my last name is Hittner, and then I say my name plus my last name, it sticks them together, and it sticks them together without a space, right? Because I didn't actually give it a space. So you can fix that. You can say, I won't copy over the top of it because so you can see what the difference is. You can actually add another string with a space. So you can add a string. So this is basically, so adding for strings is basically appending them, like you append the next thing onto the next thing. And there you go. I stuck a space in the middle by adding a space. So I literally just added the plus signs there. So I added a space into the middle of the string and it took it. So the space, I left a space between the quotes. So the lists are kind of like that. So it kind of appends the one onto the other one, which, like I said, is not what you might think if you're thinking they should act like arrays. So if you have a list of numbers and you want them to add like arrays, like which is in a sense like the components of a vector, you're going to have to use an array. We've already seen, like I said, we've already seen at least one array, which was the linspace, and I'll show you how to create new ones from scratch today, other than just linspace. So, question so far? So other funky things that don't work that you might think might work: 2 times a list. Again, if this is an array, it would do what you expect it to do. Now that you know it appends, what do you think that will do? 2 times the thing is like the thing plus the thing, right? So it's going to append itself. So it does the 1, 2, 3, 4, 5, and then another 1, 2, 3, 4, 5. So rather than like multiplying each term by 2, which is what will happen in an array. So if a list is a array, it will do what you expect it to do mathematically. Like I said, these are acting like strings, and it's just appending the one onto the other. Similarly, some things will just literally not work. So it doesn't know how to do a list plus 1. So showing you that error message on purpose, it doesn't know how to do that. It would know how to do, at least I'm pretty sure. I might have to put it in square brackets. We'll see if this works or if I have to put it in square brackets. Yeah. Well, maybe it doesn't even work to put it in square brackets. We'll find out. Yeah. So then, yeah, that's the previous error message from the +1 without the square brackets. So if you put it in square brackets, you're adding a list to a list. So even though I'm saying it's acting like integer or like strings, it has to be a list. So it's appending one list to another list. So I put the square brackets around. It's a list of one object, the integer 1. So you can append lists, and you can't just append a number to a list. So very much not like arrays, which brings us into why we need arrays. So the arrays, let's go ahead and do a text box. So that was lists and then arrays, which you've already seen before. Oh, notice I had not imported NumPy or math yet. NumPy. So let's do that. Import NumPy as MP, my favorite way to do it. And then I'll need the NP prefix in front of everything. Let me scroll up. So, I'll just call it ARR for short for array. So I don't have to type out array np dot array. Okay, now I need round brackets for the So we haven't talked much about functions yet. Basically, functions come with round brackets, and we've seen several. Print is a function. So you put print and then you use the round brackets and it prints whatever you put inside the round brackets, right? And then type. Type is also a function. You print type and then you put in round brackets, you put X or Y or whatever variable name, and it will show you what type it is. So the round brackets go with the function, and then the square brackets would have made it a list in Python, but now it's in the round brackets in the NumPy array. So it's actually going to make it an array for us. So R is that, print an array is, R. Okay, so again, in the round brackets, what I'm telling it to print goes in there, and the round brackets go with the function. And it has type, they're saying type is a function. It has more round brackets, and then we put the variable name in there, and it should be showing up in our variable inspector. But again, so that this Jupyter Notebook itself has all that list, I'm showing you what it is. Now notice it doesn't say 5 items anymore. So a list says 5. Oh, by the way, there's nothing special about 5. So we can make them of different sizes, just like I want enough to show you and not so many that none of us want to type all that out. So, and there are shortcut ways to do these too. So there's my array, my first array, and it's class NumPy ND array, which we saw before because we saw for the linspace. And we can let's make some more so we can add them exactly as we expect. NP array, round brackets, square brackets. Let's make a solid one of just 10, because then easily nobody has to think of what it's going to do when we add it. Now you should be able to add them. Now you should be able to say R plus R2. I now realize that ARR is a bad choice because when I say it out loud, it sounds like I'm saying the letter R. R, ARR, the array, first array plus the second array. Now that does what you were probably expecting. Where it adds each term. So it adds the first entry to the second entry to the third entry to the fourth entry, which is probably what you expect. You can also do the 2 times, and it should probably be what you expect. Remember, the original one is the 1, 2, 3, 4, 5, and the second one is the all tens. So the first one was 1, 2, 3, 4, 5. So if you multiply each element by 2, which matches vector math, if you multiply a vector by a scalar, it multiplies each term of arrays are not identically vectors, but you can use them as vectors. You can also just use them as a set of numbers like we were doing for the time. In the graphing, when we used linspace, right? I don't think of time as a vector, but it's just a bunch of different numbers that you so that you can plot. Let's see. Any other math that we want to do? Oh, plus I also added one. So the array plus one also does what you expect. So it was 1, 2, 3, 4, 5. So it just adds one to each term. Um, that is also not that is not like vector math. Vector math wouldn't work that way, right? You'd have to write to add one, you'd have to add like to do that as with vector math, it'd have to be a vector with each one of those values. So there's something that's actually funky and not like regular traditional vector math. There is a way to make it like linear algebra, and we will talk about those commands at some point, but probably not today because I'm throwing too much at you at once. Um, I want to show you indexing. And I believe this works for lists too. Let's just print, oops, not capital. Print RA, just so you have it. I know it's over there in the variable inspector. So now this will be slightly annoying. Okay. Let's see, there's probably a way for me to show you I'm going to do R, and I'm going to do the square bracket, not the round, R of 0. Python starts with the index of 0 instead of 1. R of 0 is 1. R of 1 is going to be 2. R of 3 is going to be 4. Oh, did I skip one? I did skip one. That's all right. So the index is the place of the, so like a three-dimensional vector, you have the x, y, and the z component, and you probably, not too many of you, a couple of you may have taken classical mechanics before, like the upper division one, and at some point you'll start calling those the x1, x2, x3 coordinate rather than having to write separate letters. That's also useful in programming. So the index is kind of like telling you which component, and Python starts at 0. So what it means is the 0th component of the array It's really, I said that. I tend to think of it as vectors, but it's really, there are places where they really don't act like vectors, so that's slightly dangerous. So the 0th component is the first one, which is kind of annoying when you've named it when you've named it like that. You can also this. I'll just well, as long as I'm just debating. Sorry, that was just a pause about what order should I show you some things in. You can actually index them from the opposite side, and if you do that, I don't do this. I almost never do this, but you can. So if you index from the opposite side, you use negative signs. So if I do array -1, it will start pulling from the right instead of the left. And this time it doesn't have the 0, right? So I guess the 0 would be sort of off the chart. You need the minus sign to tell it where you're pulling from, right? But -0 doesn't really make any sense. So -1 is the first one on the right. So it went 1, 2, 3, 4, 5. So kind of like the wrong, so it's the first place on the right instead of the 0 is the first one on the left. Ugh. You can also pull slices. So it goes from 0 to 4 because there are 5 of them. I could do 1:3, and that should pull the middle of the array. So it pulls a 2 and a 3. Oh, it doesn't go up to 3. So it actually does 1 less than, I forgot that. So it actually does 1 less than what you might think. And this is a thing in Python. 1 to 3, and I could pull 1 to 4 to get if I want the 2, 3, 4. So there I go. I pulled out of the middle. So that is, we're not going to do a whole lot with it now, but I mentioned it now because there are times occasionally where it comes up and where it's very helpful to know that that is the case. I was debating, but it's a good refresher. I talked way longer already than I thought I would, but that's okay because Only some of you, if all of you were there, I would have been more tempted, but since you're all not there, I will let some of this go. Let's do a little bit of plotting, because also I can show you how a simple array plots. A little plotting. We need to pull in our import matplotlib dot pyplot as plt, and then let's just leave that as its own cell. Why not? Just in case I keep. This is the thing. I often do that, by the way. I often, once you get started, I have a set of libraries I just import in the first cell every single time. And then you don't have to keep rerunning them if you keep rerunning your code. Like if you want to change a value, now I can do plt.plot. Now I can do something we haven't done before. So far we've had to plot two arrays, the t and the x, to get like the plot of x versus time. But if I just plot array, it will actually do something. What it does, I mentioned those indices, it's actually using the indices to plot. So it's actually, so these are the values of the array. It goes up 1, 2, 5. It goes up 1 to 5. So so the y-axis is the value of the array. I should do, instead of r, I should do the 2s. Oh no, because that's so boring, because it's, well, let's do 2 times r. You also do that. So it will take, so on the bottom, so you can tell on the bottom that the scale goes from 0 to 4, not 0 to 5, because that's 0, 1, 2, 3, 4, right? So it's always one less. So it's always one less than you think it should be, because it starts at 0. And now the y-axis is clearly the one with the values. I wanted to make clear which was the values and which were the indices. So it actually, I had to mention the indices for this plot to make sense. So it's actually plotting the value. If you just give it one array instead of two arrays, if you give it two arrays, it'll plot one array versus the other array. Like if you give it t and x and they're both arrays, it will plot the second one on the y-axis. But here we go. If you just give it one array, it will actually use the indices, which is pretty smart of it, because then it's a really quick way. Oftentimes it's a faster way to visualize an array rather than trying to, if you have a really big array, you don't want to look at every single number by hand. And so this is a really, really good way to do it. Oh, I didn't do, you all have done though, and it didn't bother anyone. Array, because you've done t squared, right? So the array squared. This is another one that is not the dot product. So if you multiply it, so if in math writing, if I wrote a vector squared, I'm gonna put this is important enough to put a text cell. In math, if I square a vector, it becomes a scalar. If you think about the dot product, it is the dot product. And if you think about the dot product, remember the easy way to do the dot product is, so for instance, d squared equals the magnitude of the first one times the magnitude of the second one times the cosine of the angle between them. Don't worry about my LaTeX. There we go. If you see the right-hand panel there, it looks, that's what, so dot product is magnitude of the first one, magnitude of the second one, cosine of the angle between them. But if it's the same vector, then the cosine has to be 0. And so it's v, I already did it with like, so v squared is just v times v. V times v times cosine of 0. Because if it's the same vector, they have to be along the line with each other. So that's why, so multiplying a vector in math is doing a dot product, and it just becomes the magnitude squared. But that's not true if you just naively in Python. But in Python, if you square an array, like you square a number, just using that, square a number with the, as the exponent, it squares each element of the array. So in Python, if you square an array like you square a number, it just squares each element of the array. That is very much not math. There is a way to do it like a dot product. There are a whole bunch of, I believe it's .lin alg in NumPy. We will get there, but we will not do that today. There's just, like I said, that's a lot. I'm going to stop. I've thrown way too much at you now. in Professor Lee's book, another text cell, which I have to give you, in Professor Lee's book, you can skim over chapter 3 and chapter 6. I know I'm going in funky order. That's one problem. I did go in a slightly different order than he went. And this will become homework. We're only on 2, right? Exercises, which are scattered throughout the chat. I mean, they're in order, but they're in you have to skim along to find them because they're in between the text. You do not have to read it because it's mostly just what we just did here today. Exercises in the chapter 4, 5, and then 11 through 16. Most of them are super, super short. Most of them are, the first 2 are literally like type the line that does this, and it's just like multiplication. So most of those, even though it sounds like a lot, but most of those are super, super short. That will become homework. I'll check in with you all on hopefully in person on Friday and see how those are going. Let's see. I only left us with 15 minutes, which probably isn't enough time. Is that enough time? That probably isn't enough time for you to do very much in terms of the. Oh, but if you want me to, like I said, anybody who wants to stay and ask me any questions about the ISC, please do. Otherwise, you're free to go, and I will post that. That will become homework 2, which I will put in Canvas. All right, questions for me. This Colab file that I was just typing should already be in the shared directory of this class. So you should be able to see the one I was typing, as well as hopefully you took your own notes. That's probably the most important screen to leave up.
What chapter is the 4, 5, and 11 through 16 in?
Oh, they're all chapter 3.
Chapter 3. Okay. In the book that we have on the shared drive.
In Professor Lee's book, which I will put in the shared drive right now.
Okay.
Chapter 3 of Lee's book. It's really too bad there's all these L's. Ling and Lang, Tangen, and Lee.